Okay, so we're going to look at indices. So one of the questions they can ask you is to write without using indices, and then the second type of question they may ask you is solve an equation using indices. So for each of these questions, you're going to have to go to your log tables, and in your log tables you'll find all of these rules here. And these may need to be implemented for the various questions you might get. Okay, so the first one we look at, 8 to the power of minus 2. So write without using indices means they don't want that power in your answer. Okay, so if you were to go to your calculator and you were to write 8 to the power of minus 2, you're going to get 1 over 64, okay? Which is the correct answer, but if you just write that answer and don't show your work, you're not going to get your marks, okay? You have to show how you got that answer and how you got rid of that indice or power. Okay, so 8 to the power minus 2. So you look over your log tables and see, does any of my rules look similar to the question? So if I look over here, 8 to the power minus 2, well, that looks like a to the power minus p. Okay, so I know I'm going to write my answer in the form of a over, or sorry, 1 over a to the power p. So I'm going to write out my rule first. So I'll have a minus p is equal to 1 over a to the power p. Okay, so my a, in my case, is going to be 8, and my p is going to be, so it has minus p is equal to minus 2, so my p is just going to be 2. So if I rewrite my indice, I'm going to have, so I'm rewriting it into this form here, so I'm going to have 1 over my which was 8, to power my p, which is 2, which is 1 over 8 squared, which is 1 over 64. Which is my answer. So as I said, if you check it in your calculator, it'll give you 1 over 64, but you have to show that you implemented your indice rule. If we look over here, we have 169 to the power of a half. So again, looking across, see what rule does it look like. So it looks most like this one here, because I have 1 over q, and in this case I have 1 over 2. If you look at the one below it, that would stand if I had a number, say like 27 to the power of 3 over 2. That's when you'd use the one below, because it wasn't a 1 over q. It was a number. Okay, so I'm going to write out my equation that I'm going to use, or my formula, equals q root a. Okay, so in this question I know my a is equal to 169, because that's in that place, and I know my q is equal to 2. So I fill it into my equation, so I'm going to have my square root 169, and it's the 2 in here. So you know that is actually square root, because it has the 2 in there. So you can put it into your calculator by all means at this stage, but you should know the square root of 169 is equal to 13. So again, you can check from the very beginning, 169 to the power of a half, and put it into your calculator, you should get 13. So you know you're going to have the right answer. But that's how we write our indices without using powers. Okay, and so the next part is solving equations using indices. So let me just make this a little bit bigger. Okay, so solving use equations with indices. Okay, so we have to follow a couple of rules. So our rules are just here in order to solve this equation. So our first rule is that we have to get our base to the same number. So our two bases are, we have 27 and we have 3. Okay, so we're always going to want to get to the smaller base. So if we try to get 27 in terms of 3, because we can't ever get 3 in terms of 27. So 27 in terms of 3. So we know 3 squared is equal to, just do a bit of rough work down here, 9. We know 3 cubed is equal to 27. So we know instead of writing 27, we could actually write 3 cubed. Because we've just subbed it in, put in brackets. So 3 cubed is our 27. So then we'll just write out the sum again, equals 3x plus 10. Okay, So that's our first rule done, getting our rules or getting our basis the same number. Our second rule is implement any indice rules. So we look at any indice rules we have that might match what we're doing. So 3 to the power 3 bracket 2x. So that looks like this rule here. So we know if we have a to the power, which is right here, p, q, it actually becomes a, p, q. So the outsides, or the powers just multiply by each other because they're stuck together. So if we implement that into ours, we're going to have our base stays the same, but our 3 now multiplies by our 2x. So that would give us 3 to the power 6x equals 3 to the power of x plus 10. So we've implemented our rule. Once we've done that, so we've got our bases the same number, we've implemented any necessary indice rules. Now we can cancel our bases because our bases are the same number, and we can go from there. So this will leave us with 6x equals x plus 10. Six x equals x plus 10. So that's our bases cancelled. And now we want to solve. So solve for our unknown, which is x. So 6x minus x equals 10. 5x equals 10. X is equal to 10 divided by 5. So x is equal to 2. So that's how we solve our equations using indices. So you have to remember them rules. Get your bases the same number, implement any indice rules, and solve for your unknown. In some questions, they may ask you to verify your answer. Okay, so we know that x is equal to 2. So we'll just sub back in x is equal to 2. So 27, 2 equals 3 times 3 to the power 2, so 3 squared plus 10. So that's going to be 27 to the power of 2 by 2 is 4 equals 3 to the power 12. So you're going to need your calculator. So 27 power of 4, that will give us 531,441, and 3 to the power 12 will give us the exact same thing, 531,441. So therefore we've verified our answer. Just be careful if they do ask you to verify. Make sure you don't forget. Highlight it on your exam paper and then verify it. So that is our indice questions.